We will wait for few more minutes, then we will start at 7:15. Okay, so we should start now. Can you see my screen and I am clear to you? Hello. Okay, so we can start now. Let me present the. So once again, I welcome you to the interaction session on atomic and molecular physics for January 2020 session by NPTEL. Today we'll be discussing few problems regarding the week 8 lectures or week 7 lectures maybe, because the last class we were discussing few problems regarding that. Myself Vivekanand Naik, I am a PMRF PhD research scholar in the Department of Energy Science and Engineering in IIT Delhi. So let's start with our first problem of the day. The question gives, what is the eigenvalue of H cap in the state A cos kx for a free particle? So here this H cap is the Hamiltonian and A cos kx is the wave function. Like we are discussing in quantum mechanics, the like in classical mechanics, what we do, we first calculate the position and then from position we calculate different parameters required for the equation of motion of the particle, like velocity, acceleration, force, etc. But here in quantum mechanics, each state is represented by a wave function which is known as wave function, and here the wave function psi, here the wave function psi is given as a cos kx. A cos kx, a cos kx. So this is the wave function for a free particle. We need to calculate for a free particle, and it is given that we want to calculate the eigenvalue of h, we want to calculate the eigenvalue of h cap or h operator in the state a cos kx for a free particle. So can anyone tell me what is a free particle? Which particle to which particle we can call this is a free particle? What do we mean by free particle? Uh, Not zero potential energy. We can say the potential is zero or potential is constant. That is, for a free particle, if potential is zero only, it will not satisfy, because for a free particle the force is zero. When there is no force acting on a particle, then we call the particle a free particle. For a free particle, force need to be zero, and we know what is the relation between force and potential. Can anyone tell me what is the relation between force and potential? F equals to minus del V by del R, is not it? So if we write force, then force will be derivative of potential, negative derivative of potential. So if the potential is, so here potential can be zero and potential can be constant, because when we take derivative of a constant, it is zero, and derivative of zero is also zero. So when a particle is moving in a region where it has no potential or zero potential or a constant potential, we can call it as a free particle. So, so for a free particle, we have force acting on a particle is zero, That is, it is moving in a region where there is no potential, or the potential in a region is constant. Suppose we are considering about the particle in one dimension box. Here, if here it was from 0 to L, the potential was 0, but here the potential was infinite. Similarly, if we can say, suppose here from 0 to L, the potential is V and it is infinite. So, in both cases, here the potential is 0, so there will be no force on the particle, because the spatial variation of potential results in a force. So here, since the potential is 0, force on the particle will be 0, so it is also a free particle. Here, the here also, if a particle moves in a field where there is a uniform potential throughout the region, then the particle will also experience no force. That is, the spatial variation is 0, so F is again 0. But here, when we want to calculate free particle, we will take generally the case of V equals to 0. So in case of free particle, if you take V equals to 0, here H means Hamiltonian. Here H stands for Hamiltonian. Here H stands for Hamiltonian, and in quantum mechanics, what we represent physical quantities, we represent any physical quantity in terms of a operator, an operator. So here H cap is Hamiltonian operator. So any operator represented by A, suppose A is an operator, then it is represented by a cap over its head. So this is A operator. Similarly, here H is Hamiltonian operator, and Hamiltonian operator is nothing but the total energy operator, like kinetic energy and potential energy. So, what the Hamiltonian operator represents? The Hamiltonian operator represents the kinetic energy and potential energy. So, here we will calculate the eigen value of Hamiltonian operator in this state, A cos kx. Here it is written as eigen value. So, I had told you in the previous class, for eigen value we have, suppose A is a operator and we operate it on the wave function psi, here psi. If we get some value, suppose A, and we again get the wave function in the right hand side, that is, in both left hand side and right hand side, the wave function remains same after we operate the operator on the wave function, then it is called as eigen value, and this operator is called as eigen operator. And the state psi for which the operator operates and gives a eigen value, the state is also known as eigen state. So if we operate h cap on the wave function A cos kx, then we can get a eigen value, and this value will represent the total energy of the particle. 1 minute. I'll be back in a few minutes, 1 or 2 minutes. Hello everyone, sorry for the inconvenience. So basically, in the state, in this question, we will derive the eigenvalue of Hamiltonian operator. The Hamiltonian operator gives a total energy operator. So when we operate Hamiltonian operator, suppose this is the Hamiltonian operator, we operate it on the wave function this psi, then we get some value, and we again get that operator. Then this value, since Hamiltonian operator stands for the total energy of the system, that is total energy E, then this value which we will be getting, this value will also represent the total energy of the system. So we will now calculate. How to calculate? We will operate the Hamilton operator h cap on psi. So we know kinetic energy is p square by 2m in terms of momentum. So kinetic energy operator will be px cap square by 2m, and for potential energy, if we take 0, then it will be the h operator will be only px cap by 2m. Can anyone tell me what is the expression for px cap in quantum mechanics? This is a momentum operator. What is the value of the px cap? It is minus I h cross del by del x. So since px is minus I h cross del by del x, then what will be px square? Can anyone tell me what will be px square? Hello, anyone? Am I audible to you all? Hello. So here px square will be then px square will be minus h cross square by 2m, because minus I into minus I is minus I square, and minus I square is sorry, plus I square, so I square is minus 1, so it will be minus h cross square by 2m del square by del x square. So it will be minus h cross square, h cross square it will be minus h cross square by 2m del square by del x square. So when we write it p square by 2m, then it will be minus h cross p square by 2m, then p square by 2m will be minus h cross square by 2m del square by del x square. So for h cap psi, what we will write? H cap psi will be then minus h cross square by 2m del square by del x square of psi. It will be minus h cross square by 2m del square by del x square of, here we have psi is equals to how much? Psi is equal to a cos kx. So it is a cos kx. So when you take the derivative of cos x is minus sin x, so it will be a cos x, the derivative of a cos x will be a k minus a k sin x. Then again we, if we take derivative once again, then it will be again, it will become cos, so it will be minus h cross square by 2m into minus k square, because it has kx in the theta term, it is kx, so minus k square a cos kx. Now this a cos kx is our phi or psi, that is the wave function. So it will be how much? It will be h cross square k square by 2m into psi. So what we get? We will get h psi is equals to this much. So when we compare it with this equation, a psi is equal to a cap psi is equal to a psi, where a is the eigenvalue. Then here h cross square k square is the eigenvalue. So the energy of the particle or the system will be h cross square k square by 2m. So this is the eigenvalue, or we can say it as energy eigenvalue. So this is the eigenvalue of Hamiltonian operator in a state of a cos kx for a free particle. In generally we have here we have taken v is equals to 0 for a free particle. So what we So what we got here, the eigenvalue of Hamiltonian operator is h cross square k square by 2m. And if you generally know, if we consider a particle for which v is equals to 0 or v is equals constant, then generally in classical mechanics, what will be total energy u will be kinetic energy plus potential energy, and here potential energy is 0. So it will be how much for kinetic energy? We know that for kinetic energy generally we can represent p square by 2m. Then if we put p is equal to h cross k, it is another expression for p, because we know that. So it will be h cross square k square by 2m. So this is the energy of the, generally in classical mechanics, if we consider, this will be the energy of the particle. Again here we also found that the eigenvalue of the Hamilton operator in the state psi is another particle. So does anyone have any doubt regarding this question, or we should move to the next question? So we will discuss the next question, and the next question is, calculate the expectation value of the momentum for a particle in a one-dimensional infinite potential box of length L. So for a particle in a one-dimensional infinite box potential, so we discussed this we discussed about the one-dimensional potential box in the previous interaction session. So for a one-dimensional potential box, what we have for a one-dimensional potential box of length L means, if this is a potential box and it is from 0 to L, and at 0 the potential is infinite, and at L the potential is also infinite. So this is known as one dimensional infinite box potential of length L, means the particle is in a region where the potential Vx, suppose this is x, suppose this is x, this is x, so Vx is 0 for x and infinite at x equal anywhere, or x, I mean between 0 to L, For the value of x between 0 to L, the potential is 0, and that is there is no potential, and the potential outside this region is infinite. So if a particle is placed here, then it will be called as a particle in a one dimensional infinite potential box. So here we want to calculate the expectation value of the momentum. So what we will calculate? We will calculate the expectation value, and can anyone tell me what is the for calculating the expectation value, we need the wave function of the particle in the potential, in this potential box, one dimensional potential box. So can anyone tell me what is the uh, potential, what is the wave function of the particle in nth state for a one dimensional potential box? So for a one dimensional potential box, we have generally the form of the potential is sine k, form the potential is sine kx, generally sine kx we have, but here k is equals to n pi by L. So what we get, for psi n x, we get a sine n pi x by L, where L is this length, because here it is given the potential box of length L, so L is this length, and it is n pi x by L, a sine n pi x by L. And when we normalize it, because according to the property of a wave function is always normalized. That is, what do we mean by normalized? By normalized we mean the total probability of a particle inside, the total probability of finding a particle is uniform, is unity in whole region. So here, since the potential outside the box is infinite, so at infinite potential will be 0. So at x equal to 0 potential is 0, and x equal to L also the at x equal to 0 wave function is 0, and at x equal to L wave function is again 0. So you can here put, if sine 0 is 0, then wave function is again 0, and when we put here L, then L cancels out and sine n pi is again 0. So this satisfies the condition. But here we first need to normalize the wave function, and by normalize we will, what we will do, we will integrate the wave function and its complex conjugate, because we know that wave function has no physical meaning, but however the wave function mod square has a physical meaning, and it gives the probability of finding a particle. And if you integrate it in a region dx, then it will give the probability of finding particle in a region dx. And if we integrate it within some limit, suppose 0 to L, then it will give the probability of finding a particle in a potential region where the wave function is psi nx, and the region is from 0 to L, that is the x is from 0 to L. So here similarly, when we normalize the wave function, what we will get, we will get the integration 0 to L, because since the wave function is 0 both side, so the particle must be present, inside the region of 0 to L. So when you take integration from 0 to L, and so when you take integration from 0 to L, psi, here psi n x mod square is nothing but psi n star, psi star into psi dx, which will be unity, that is 1. So what will it give? It gives 0 to L. We know your psi is a sine n pi x by L. So since it is a real wave function, then its complex conjugate will be similar. So we will get a square sine square n pi x by L, a square sine square n pi x by L dx will be equals to 1. Then if we integrate it, what we will get a, then we will get a as 2 by L root over. So here, if the normalized wave function of of a particle in one dimensional potential box is psi nx, that is nth state potential, is 2 by L root over 2 by L root over sine square sine n pi x by L. So this is the normalized wave function of a particle in a one dimensional potential infinite potential box, 1D infinite potential box. So this is the wave function, and here we want to calculate the expectation value of momentum. So in quantum mechanics, suppose A is a sorry, we have taken A before in this problem, so we can take another operator. Suppose in quantum mechanics P is a operator, then its expectation value we write it as P expectation, we write it in bracket, and it will be how much? So it will be how much when you write the expectation value. Then like in this here we did 0 to L psi n star psi dx. Here we will calculate the expectation value as integration from 0 to L. Similarly, because we want to calculate in the expectation inside the box, so it will be 0 to L psi star p psi dx. So this is the expectation value, or generally we call it as average value. So this will be the expectation value of a operator. So here we want to calculate the expectation value of momentum since it is one dimensional. So we will calculate the expectation value of momentum px. So the expectation value of momentum px will be how much? It will be integration 0 to L psi star px cap psi dx. So when you calculate it, it will be 0 to L psi star will be it will be psi star. So this is psi star. 1 minute. Yeah, this is psi star. Then the what is the value of the momentum operator in quantum mechanics? I just told you in the previous question. Anyone? It will be minus I h cross del by del x, and here it is psi, because the psi in the operator will be operated in the function psi and then dx. So here psi is sin n pi x by L. So when we take derivative with respect to x, so it will be cos n pi x by L into n pi by L. So we will get, and again here 2 by L will be there, and in psi star when you write it again, it will be 2 by L root into 2 by L root, because one 2 by L root will be coming from psi star, and another 2 by L root will be coming from this psi. So it will be 2 by L, and this minus ih cross will be there because minus ih cross is present in the operator. So minus ih cross is present here, minus 2 by L minus ih cross. Then del psi by del x will be n pi by L into sine n pi x by L, because here this 2 by L root, here there is one 2 by L root over, this psi star belongs to this 2 by L root over sine n pi x, and this psi belongs to one 2 by L root over, and the derivative of sine is cos, this is cos n pi x by L, and here it will be dx. It is 0 to L. So here it will be 0 to L, 2 by L minus I h cross n pi by L sin n pi x by L and cos n pi x by L. So here we can see here it is a familiar form of sin 2x, that is 2 sin x into cos x. So it will be sin 2x. So we can write 0 to L, then 1 by L will be outside in the, we can take the constants outside. They have nothing to do with the integration. So we can take here minus ih cross will be coming outside, minus ih cross coming outside, and here we have n pi by L, and this L it will be n pi by L square, and these two will be merged in this sin x and cos x to give sin 2x. So it will be minus ih cross n pi by L square, n pi by L square, integration of 0 to L sin 2n pi x by L, because it was n pi x by L. So when we call when sine we do sine 2x or sine 2 theta, then it will be sine 2n pi x by L into dx. So can anyone calculate the integration for me and tell me the value? What will be the integration 0 to L sine 2n pi x by L dx? Anyone? It will be how much? Once again. Okay, so let's solve it. So it will be minus ih cross n pi by L square. Sine, the integration of sine is cos, so it will be cos 2n pi x by L 0 to L. So one of you is saying 0, so we can calculate and check. So when you calculate it, it will be cos 2n pi x by L into so into it will be L by 2n pi. So here n pi gets cancelled out, 1L and this L gets cancelled out. We get minus ih cross by 2L here, but here cos 2n pi x by L. So when we calculate cos 2n pi, it will be how much? Suppose here we calculate when you put here in place of x we put L, then it will be cos 2n pi, minus when you put here 0 it will be cos 0. So what is the value of cos 2n pi? Anyone? It is 1. So cos 2n pi is 1 and cos 0 is 1 again. So 1 minus 1 it is 0. So it will be minus I h cross by 2L into 0. So 0. So what we got here? Here we got the expectation value of momentum is 0. So can anyone tell me what does it indicate physically? Can anyone tell me what is the physical significance of this result? That is when we calculate the expectation value of momentum. So when we calculate the expectation value of momentum in the one dimensional potential box for a particle, then the expectation value comes out to be 0. So can anyone tell me what is the physical significance of this result? Why it is coming out to be 0? There should be some value, because if we are spacing the particle here, it can it will move. So it should have some values, but why it is 0? Any guess? What might be the thing it is coming out to be 0? No, it's not about not finding the particle, because here if we are taking the only if it is if here there is no px cap, only we are taking psi star x psi dx, then that represents the property of finding the particle. But here, since we are taking the since here we are taking the expectation value of momentum, that will not be the probability, because it will be the probability of the it will be the average value of the momentum inside the box. So generally it is, suppose the expectation value like we do in classical mechanics. 1 minute, let me add another slide to it. So in classical mechanics, what we do, suppose we need to calculate the expectation value. Then what we do in case of expectation value, suppose in classical mechanics, suppose we throw a dice, then we have 1 2 3 4 5. Then what will be the 1 2 3 4 5 6? Then what will be the average value? Can anyone tell me? Hello. So basically, since we are talking about expectation value or average value, we need to consider the probability. So here, the probability, if we throw a dice, it has from values 1 to 6, that is 1 2 3 4 5 6, and the probability for each value is 1 by 6. So when we throw a dice and it has 6 faces, the total probability will be 1 by 6, 6 times, that is it will be 1. So this 1 is normalized. So the total probability of getting any of these value, that is either we can get 1, either we can get 2, or we can get 3 4 5 6, like that. So out of these 6 values, any one will definitely come. That's why it is normalized. So each have a probability of 1 by 6. So when we calculate, so it will be how much? Suppose we want to calculate the average value of a particle, average value of a number, then it will be its number into its probability by total probability. So 1 gets cancelled out, so 1 by 6. So this 1 by 6 represents the average value or expectation value, that is if we throw dice 6 times, so there is possible that 1 will come only once in 6 times. So generally similarly here, if we can see here, the this is a quantity which is a vector quantity. Momentum is a vector. So since the particle is present inside the box, it can move anywhere, that is it can move in plus x direction, it can move in minus x direction. So this since it can move in any direction, that is both plus and minus direction, so its average value is 0 here. So the particle have the possibility that it can move in plus x direction and it can also move in minus x direction. So this is the physical significance of this case. So since the particle can move in any direction, so when you take average, suppose here we have 1 minus 1, then we will get 1 into 1 by 6, then plus minus 1 into 1 by 6 by 1. It will be 1 by minus 1 by 6 minus 1 by 6 get cancelled out, it will be 0. So since here the momentum can take both value, that is positive value as well as negative value, so the total average value will be 0. So basically here generally for a uh, state or wave function psi, if we are calculating the expectation value of a operator, we represent it as psi a psi divided by psi psi. So this is the expectation value. So here these notations are called as Dirac notations. You must have heard about it in the lectures. So here this is not this expression, like when we write psi a psi, it is nothing but integration from, generally take integration minus infinity to plus infinity psi star a cap psi dx, and this psi means integration minus infinity to plus infinity psi star psi dx. So this psi star psi is psi x mod square. So since in the calculation first we normalize the wave function, so this is a normalized wave function. This wave function is normalized. So due to this normalized wave function, the integration psi star psi dx integration, it will be 1. So here this value will be 1. So we will be only integrating from minus infinity to plus infinity. If we take a normalized wave function, so we will take minus infinity to plus infinity psi star psi dx. So in this case, we first normalize the wave function and then we calculated the average value or expectation value of the wave function. So in this way we can calculate the average value of any quantity. Suppose here I will place any operator. Suppose I will put del square by del square psi by del square. Then we can again calculate the value. So this is the way we can calculate the expectation value of a physical quantity. Here we calculate the expectation value of the momentum. So uh, does anyone have any doubt regarding this question? So what we do, what we did in this question is, here we want to calculate the expectation value of momentum for a particle in a one-dimensional infinite potential box of length L. So this is the potential form of a one-dimensional infinite box potential. For a one-dimensional infinite box potential, the potential in a region of x from 0 to L is 0, and the potential outside this region is infinite. So when we calculate in this region 0 to L, we will put for potential we put V equal to 0. So we know the wave function of a particle in a one dimensional potential box is given by psi nx a sin n pi x by L, where a is a normalization constant, and the way this wave function is not normalized, it will be normalized when it will be normalized when the integration from 0 to L psi n star psi dx will be 1, then it will be normalized. And when we put the value of the wave function in this relation, we got the value of a is 2 by L. So the normalized wave function of a particularly one dimensional potential box is psi nx is 2 by L root over sin n pi x by L. And according to quantum mechanics, to any quantity, we can, if we want to calculate the expectation value or average value, so it will be Pn, it will be psi star Pn p psi star px cap psi dx, and the operator notation of momentum operator is minus ih cross del psi by del x. So it is psi star minus ih cross del psi by del x into dx. So when we calculate the integration, we got 0. So the expectation value of momentum for a particle in a one dimensional potential box is 0. So the particle can have any value of momentum with equal probability, because when the particle have any, suppose like in this example, if we do another thing, that suppose we suppose there are different values like 1 minus 1, 2 minus 2. So 2 minus 2, so when we calculate the average value, then it becomes 0 definitely, because we add all these, so it will be 0 by 4, it will be again 0. So that's why, if since the momentum can attain all possible value, that is negative as well as positive, so the average value of the momentum in the uh, so the average value of the momentum for a particle in one dimensional potential box is 0. So I hope everyone understood this problem. So we can go to the next problem, and this problem gives, calculate the energy of a particle in a potential V is equals to 1, b is equal to half m omega square x square, having wave function psi equals to x exponential minus m omega x square by 2h cross. So this is the potential. In first case, we calculated the energy of the particle. Here first question we solved, here this h cap is nothing but the inner total energy, but here it was a free particle, so we took v equals to 0, and this was the state. Similarly, here in this case, we have, this is the potential, and the wave function of the particle is x exponential minus m omega x square by 2x. So can anyone tell me, from by looking at this potential, can anyone tell me what is this potential is otherwise called as? It seems a similar form of potential, is not it? V is equal to half m omega square x square. This it has some name. Can anyone tell me what is the name of this potential? Sorry, once again. Yes, it is a harmonic oscillator potential. So when we plot it, since it is x square, so it will be like this. For negative value of x also, potential will be positive. So this is nothing but a simple harmonic oscillator potential, and we know the wave function of the wave function of a particle in a potential of simple harmonic oscillator potential is somehow like this. But however, here we want to calculate the energy of the particle. We don't know the, so can anyone tell me what is the eigenvalue of energy for simple harmonic oscillator potential? Anyone know? It is n plus half h cross omega. So here, but here there is no n. Suppose we want to calculate the expectation value of for the expectation value of energy for ground state. Then ground state n will be 0. Here n can take value 0. So n is 0, 1, 2 like this. Here it is V and it is X. So here if we calculate the ground state energy, it will be E0 half h cross omega. Then for n equal to 1, it is 3 by 2 h cross omega, like that. So the separation between them is h cross omega, that is h nu. H nu can otherwise be written as h cross omega. So h nu is the what is h nu? H nu is the energy of a photon. So this is a, so the minimum quantized energy value is h nu. So this is the difference between the two energy levels for a simple harmonic oscillator. And for a simple harmonic oscillator, we can have different energy levels corresponding to n equal to 0, 1, 2, 3 like that. So here E0 is ground state. It has energy, so it is also known as 0 point energy. So half it is half h cross omega, and E1 is 3 by h cross omega, like that. Then 5 by h cross omega, like that. So here we want to calculate the same energy, but we want to calculate by using the wave function, this wave function. So when you calculate the expectation value of energy, what we will do, we need Hamilton operator. So Hamiltonian is nothing but H equals to how much? H is kinetic energy plus potential energy. So it will be kinetic energy plus potential energy. Or we can put it in Schrodinger's equation. We can calculate the value in Schrodinger's equation, because we can directly calculate from Schrodinger equation, or we can calculate by putting it in Hamiltonian. So when we use Schrodinger equation, then can anyone tell me what is the Schrodinger equation? What is the form of Schrodinger equation? This H psi equals to E psi is nothing but the Schrodinger equation, and when we write it, H psi is kinetic energy plus potential energy, that is px square by 2m plus v into psi equals to E psi. E psi. So we know px is, we have frequently discussed about it, px is minus ih cross by 2m, sorry, minus ih, px is minus ih cross del square by del x square. So it will be how much? Minus h cross square by 2m plus v psi equals to minus h cross square by 2m del square by del x square plus v psi equals to E psi. So it will be how much? Minus h cross square by 2m del square by del x square psi plus v psi equals to E psi. So when we take this v into that side, it will be E minus v psi equals to how much? Minus h cross square by 2m del square by del x square. So this is one form of Schrodinger equation, and if we take 2m by h cross square to that side, then what will be the Schrodinger equation form? Another form we can write, it will be del, because this minus h cross square time we take to that side, it will be 2m by minus 2m by h cross square, so del square here it is psi. So del square by del a square psi is equals to minus 2m by x cross square e minus v psi. So this, when we represent del equals to del by del x, then we can write it as del square psi plus 2m by h cross square e minus v psi equals to 0. So this is nothing but the nothing but Schrodinger's equation, and this like in classical mechanics we use F equals to ma, and from F equal to ma we derive all the expressions in classical mechanics. In quantum mechanics, from Schrodinger equation we here we got for x equal to m we had to use d square by d square by dt square of x equal to m into acceleration is d square by d square x by dt square is equal to f, and from solving this we can get the equation of motion. Similarly, in quantum mechanics, the Schrodinger equation, when we have the value of psi, that is the wave function of a system, or the wave function of a particle in a system, then we can put the value of psi, and we can take the, since del is del by del x, so it is del square psi plus 2m by x square e minus b psi is equal to 0. So when you put all the values you can calculate. So for this case we have the wave function is x exponential minus m omega x square by 2h cross. So first we need to calculate the double derivative of psi here. So first we will calculate the single derivative, then while needing few more slides. So the wave function psi is x e to the power minus m omega x square by 2h cross. So x is minus m omega x square by 2h cross. So this is x. So when we take d psi by dx, then what will be del psi by dx, so del psi by del x, so it will have two terms. So and derivative of x is 1, so it will be e to the power minus m omega x square by, sorry, so it will be e to the power minus m omega x square by 2h cross plus x into the power minus m omega x square by 2h cross into 2h cross by minus, sorry, it will be into minus m omega by 2h cross into 2x. So when we calculate this, 2 will cancel out, this x will be x square, and we take, if this term we take common, then it will be e to the power minus m omega x square by 2h cross 1 plus, this will be x square minus m omega x square by h cross, so here it will be negative not positive, so it will be minus m omega x square by h cross. So again if we d square phi by dx square, so if we again take derivative, so please differentiate it once again and tell me the value. I will write it what will be the value after we take derivative it twice, because I am finding it bit difficult to write it step by step. So please calculate the, please derive the double derivative of psi and tell me. I will write it here. So we will again differentiate the above value, e to the power minus m omega x square by 2h cross 1 minus m omega x square by h cross. So when we calculate, we will be having one x term and another is x cube term, because when you calculate m omega x square by h cross, the derivative of m omega x square by h cross, there will be 2x, so that will be one x term, and when we take this term, then it will be 2x into this x square term, it will be x square into this x term, it will be x cube. So when we calculate and take again derivative, so it will be coming out, it will be this will be, yes, once again. No, there will be two terms, this e to the power minus m omega x square by 2h cross will be there, and here it will be minus 3 m omega x by h cross. One will be coming here, when you take 2 it will be minus 2 m omega h cross by square, so one will be coming here, minus omega h cross, because 2 will be cancelled out, and we will get 1 here, we will get m omega x by h cross from here, and from this derivative of this we will get 2 m omega x by h cross, so it will be minus 3 m omega by h cross, and from derivative of this term we will get plus m square omega square x cube by h cross square. So this is the mm, uh, double derivative. So when we put this in this relation, so when we put this, so we will first put this. This is the del square psi. So this del square psi will be 2m by h cross square e minus b into psi. So this del square psi will be, this is del square psi, so del square psi will be this much plus 2m by h cross square e minus b is half m omega square x square into psi. Psi is x exponential minus m omega x square by 2h cross. So here you can see this term minus m omega x square by 2h cross and minus m omega x square by 2h cross is common. So when you put here del square psi, this term we can take common, so this term will be cancelled out here. So what we will get, so after cancelling out the exponential term, we will get minus 3m omega x by h cross plus m square omega square x cube by h cross square plus 2me by h cross square and minus m minus m square omega square x cube by h cross square equals to 0. Now these four terms, from where these four terms came, this is one term, this is one term, and when you multiply 2m e by h cross square, this is one term, and when you multipy it again, 2 gets cancelled out, the negative term comes from here. So this negative term comes from this this term is this negative term, and the e term is this one, and the remaining two term coming from this. So this will get when we cancel the exponential term, we take common and multiply it divided by divide it with 0, then we will get 0 on the right hand side also. So when we calculate this term is equal and negative, so they will get cancelled out. Then it will be how much? It will be 2me by h cross square 2mex. So it will be 2mex because this x is there, so it will be 2mex. So this minus 3 will be in that side, so it will be 3m omega x by h cross equals to 2m ex by h cross square. So we will get e equals to m cancels out, 1 h cross here cancels out, there will be only 1 h cross, so when you get h cross that side, so 3 by 2 h cross omega. So what we got, so what we got here is E equals to 3 by 2 h cross omega. So this is the energy of the particle in a potential region, being potential of the form v is equal to half m omega x square, whose wave function is psi x exponential minus m omega by x square. So when we first discussed about the eigenvalue relation, then we get here for equal to 1, it is 3 by 2 h cross omega. So from the derivation we also got here 3 by 2 x cross omega. So the wave function psi is x into the exponential term is corresponding to the wave function corresponds to n equal to 1, because actually the when we solve the Schrodinger equation, then the result will be a differential equation. Then the and differential equation is of the solution of the differential equation will be of the form of a special polynomial which is called as Hermite polynomial, and this polynomial has the for n equal to 1, this polynomial has the form like this. So hn, so generally the polynomial has from h0 x it is 1, but for h1x, for h1x it is x. So this x into exponential term is coming from h equal n equal to 1. So when we put the n equal to 1 value in the eigenvalue relation, so when we put here n equal to 1, then also we get 3 by 2 x plus omega. So in this way we can calculate from Schrodinger's equation the, if we have, if we are given with a wave function of certain form, then by applying the Schrodinger's equation, minus h cross square by 2m del square psi by del x square plus v psi equals to e psi, we can calculate the value of e. Also then another method is like that, the when we calculated this, okay, here we did the same thing, but here what we did, we direct calculated SI is equal to ESI and we get the value of E. So similarly again, if we would have taken the Schrodinger equation here, we will, if we solve this question also with Schrodinger equation, then we can again get the same value, that is E is equal to h cross square by 2m. So if we solve by putting v equals to 0, if you solve, then we get E is equal to h cross square by 2m. So similarly, this is the way to derive the energy value given a wave function. So is there any doubt regarding this question? Anyone? Hello, am I audible to you all? So do you have any doubt regarding this question, how we derive the value of E? Okay, so we can move to the next question. So sorry, yes, no, no, there, for some questions there are no short tricks. Like here, if we know the wave function, if you have remembered the form of the wave functions, like I said, if this from if you have if you have studied the studied the wave functions of the harmonic oscillator potential, then you must have come across these relations and the function of the form of this form of this wave function, and from this wave function you can directly tell the energy, the eigenvalue is this. But there are some, but there may be some questions here. It is a known potential. This potential v equal to half m omega square x square is a known potential, so its wave function is known. But sometimes there may be questions like v is equals to a x to the power 4. There will be another problem. There may be some problem. I think there are some questions in net. In that case, you need to solve it and you will calculate E. So you have to solve it because in net we, this type of question comes with 5 marks. So you have to invest some time with it. So in after that you can calculate and get the result. So for some questions there are no short tricks. For some questions there may be some short tricks which you develop after solving a few problems. But here there are no short tricks. You have to solve the Schrodinger equation to get the value of a, to get the energy value if the wave function is given and the potential is given. Is that clear to you? Okay, then we will move to the next question. These questions will not be much lengthy. Here we want to calculate the total magnetic moment for 2D 5 by 2 state. So can anyone tell me for 2D 5 by 2 state, what is the value of L, what is the value of S and what is the value of J. Anyone? Please, I request you to take part in the interaction. Then only it will be beneficial for me also and for you also. Because if you don't ask any doubts or you don't respond to my question, then what I have to say, I will say. I will not say any extra things. If you ask me, then I will talk about some extra things. Basically, I try to talk about few things that will help you to understand the question better or to solve the question better. So, if we are taking here 2D 5 by 2, so for 2D 5 by 2, generally we represent the spectroscopy term as 2s plus 1 L J. So when we compare, for D, L will be 2, 2s plus 1 is equal to 2, so S will be half and J is 5 by 2. And here we want to calculate the total magnetic moment, and for total magnetic moment we need to calculate we need the total angular moment of quantum number, which is j is equal to 5 by 2. And we had discussed in this intersections that the total magnetic moment mu is given by gj, j into j plus 1 root over eh cross by 4 pi m, or eh cross by 2m, sorry, eh cross by 2m. Because when we calculated it, it was minus mu b into L. So E is crossed by 2m is nothing but mu b for. So when we calculate the magnetic moment was basically in the form of mu. For when you calculated the angular orbital magnetic moment, then it was total mu L was it was something like uh, mu b into L vector, and in place of L vector what we write, eh cross, so it is e by 2m, sorry, not mu b, it is e by 2m. So it is L is uh, so from quantum mechanics, value of L is h cross L into L plus 1 root over. So when we put here EH cross by 2m, so EH cross by 2m is nothing but Bohr magneton, and L into L plus 1 like that. So it will be another term called as GL, which is known as gyromagnetic ratio. And here is also, it is G, here it is called as Landé G factor, and it has some expression how we want to calculate D, how we will calculate G. Then the expression for G is given by 1 plus j into j plus 1 plus s into s plus 1 minus l into l plus 1 divided by 2 j into j plus 1. So here we have j equals to 5 by 2, s equals to half, and l equals to 2. Once again I am saying, because here it has given calculate the total magnetic moment. So for total magnetic moment we need the total angular momentum quantum number. So it is total angular momentum quantum number is 5 by 2, and the magnetic moment relation is gj, j into j plus 1 eh cross by 2m or eh by 4 pi m. So it is 2m. Let me write it clearly more. It is e squared by 2m gj j into j plus 1. So first, for this particular state, we have to calculate gj value, that is the g factor for total magnetic moment quantum number. So please put this value l equal to 2, s equal to half, and j equal to 5 by 2, and calculate what will be the value of g for this case. Anyone who have calculated? So when we calculate it, what will be the value? It's not J, it will be this will be G, not J. J is 5 by 2, it will be G. So let's calculate it. So when we calculate it, we will have it will be 1 plus J is equal to 5 by 2. So 5 by 2 into J plus 1 is 7 by 2 plus S into S plus 1. S is half and S plus 1 is half plus 1 by 2 is half plus 1 is 3 by 2. So 1 by 2 into 3 by 2 minus L into L plus 1. L is 2, so it is 2 into 3 divided by 2 into 5 by 2 into 7 by 2. So 2 gets cancelled out. It will be 1 plus 35 by 4 plus 3 by 4 minus 6 divided by 35 by 2. So 35 by 4 plus 3 by 4 is 38 by 4. So it will be 1 plus 38 by 4 minus 6 into 35 by 2. So it will be 2 by 35. So 1 plus it will be 38 minus 24 by 4 into 2 by 35. 1 plus 38 minus 24 is 14. 14 by 4 into 2 by 35. So 2 gets cancelled out. The 2 is 7 and this is 5. So we get 1 plus 1 by 5, that is 6 by 5. So this is correct. So here what we got, 6 by 5 is the value of G. So this G is 6 by 5. So when we put all other values, then what will be the value of mu then? So when we put here mu is equal to G. G is 6 by 5 into J into J plus 1. J is 5 by 2. So 5 by 2 into J plus 1 is 7 by 2. The square root of 5 by 2 into 7 by 2 into EH cross by 2m or EH by 4 pi m. What will be m here? It will be m is for electron. So if we know the mass of electron is 9.1 in 10 to the minus 31 kg. So when we put all these values, we have H is equal to 6.6 into 10 to the power minus 34 joule into second, and mass of electron is 9.1 into 10 to the power minus 31 kg. So put all the values and we calculate and tell me the answer. We can represent it in joule per Tesla. Magnetic moment relation is joule per Tesla. So can anyone tell me what will be the value of mu for this case? So please calculate, put all the values. Mu equal to g into j plus 1 root over g is 6 by 5. J into j plus 1 root over is 5 by 2 into 7 by 2 root over, and e h cross by 2m. We know e is again 1.6 into 10 to the power minus 19 coulomb. So put all these values and calculate what will be the value of magnetic moment. So when we put all the values, what we will get, the value will be 3.298 into 10 to the power minus 23. This will be the value. So the magnetic moment mu. So if an electron, electron is present in a state 2d 5 by 2, the magnetic moment for the electron will be 3.298 into 10 to the power minus 23 joule per Tesla. So we will go to the next question. Or if you have any doubt, you can ask me regarding this question. Then we will go to the next question. Anyone have any doubt? You can ask me. So let's go to our next question. The question is, determine the possible terms of a one electron atom corresponding to n equals to 2. So we have n equals to 2 and one electron atom. So there is only single electron. For single electron, we know S is equals to half. So we have single electron S equal to half. But for n, what is L value? So L is 0, 1, 2 up to n minus 1. So for n equal to 2, the L value will be how much? L value will be 0 and 1, because the maximum value of L is n minus 1. So from 0 to n minus 1, so L value is 0 and 1. So for L equal to 0, we have S, and for L equal to 1, we have P. Since here it is given one electron atom, so we will consider only one electron. So this small L is also equal to capital L, and this S is half. So here S is half. So we have L and S value. This is L value, this is S value. So we will get J value. So L is 0. For L, S will be half, and for L equal to 1, S will be again half. So this, if we add vectorially, we know for J it will be L plus S up to L minus S mod, or S minus L mod, whatever maybe. So it will be 0 plus half, it will only give half, but 1 and half will give half and 3 by 2, because 1 plus half is 3 by 2 and 1 minus half is half. So we will have 3 j values, that is half and half 3 by 2. So for L equals to some value, S equal to some value, we will get j. For L equal to 0, S is half. So for L equal to 0, S is half. So J is half. For L equal to 1, S is half, J is half, and 3 by 2. So we know spectroscope notation is 2s plus 1 Lj. So for this, since S is half, so it will be how much? It will be 2. 2s plus 1 will be 2. Here it is 0, so it will be S, and J will be half. And for 1 and half, so it will be again 2, but for L equal to 1, it will be P. So 2P half, and this will give 2P 3 by 2. So N equal to 2, it gave, it was one state when we considered only N, but when we considered it as the LS coupling, when we introduce the effect of LS coupling, we got three states or three levels, and these three levels are 2s half, 2p 3 by 2, and 2p half. So we can, since n equal to 2, these three states can be written as 2, 2s half, 2, 2p half, and 2p 3 by 2. Because we write, generally we write here as n, 2s plus 1 lj. So for n equal to 2, we got three different states, that is 2s half, 2p half, and 2p 3 by 2. And so the states can be represented as 2 into 2s half, 2, 2, 2, 2s half, 2, 2p half, and 2, 2p 3 by 2. So anyone have any doubt regarding this question? So what we can do, we can solve another question like this. Suppose I again told you for n equal to 3. Can anyone tell me, if n equal to 3, then what will be the different number of states? Because n, for n equal to 2 we got these things, but n equal to 3, then what we will get? For n equal to 3, L and S. For n equal to 3, we will get L values 0, 1, and 2. Is not it? Then for these values, L will be 0, S will be half, L will be 1, S will be half, and again L will be, L will be 2, and S will be half. So these two states will be similar, that like the three states we got in the previous question. And for L equal to 2 and S equal to half, we have J is equal to 2 minus half and 2 plus half. 2 minus half is 3 by 2, 2 plus half is 5 by 2. So if we write these in terms of spectroscopy notations, these three terms will also be present there, and additional to these three terms, we will get For spin half, we have double state, so 2. So it is 2. For L equal to 2, it is D. So 2D, 3 by 2, and 2D, 5 by 2. So for N equals to 1, we would have, for N equal to 2, we got 3 labels. And similarly, for N equal to 3, we got 5 labels, because there are 3 labels and these are 2 labels. So for N equal to 3, we got how many labels? We got 5 labels. Is it clear to you? Hello? Is it clear to you? Is it clear to you all? So, do you have any other doubts regarding the lecture? So, I will try to resolve them. We have a few minutes more, or should I solve any other problem regarding this type of problem? Should I solve, or you can ask me any doubt if you have from the class. Sorry, one more, once more. Okay, okay. Once again, uh, for 1 minute, I am writing it. You are talking about non-equality electrons of N and S, of S and P. S and P. For S, what is L value? Hello, tell me. For S, what is the value of L? 0. That is L1. For P, what is L value? How much? 1. So L1 plus L2 will be how much? 1 only. Hello, is not it? So uh, if we talk about S, then for this S means here spin, not this S. So for this S1 is half, this one is capital L, because this is L1 plus L2 vector. So 0 plus 1 or 0 minus 1, it will be 1 only. So L has only one value, that is. But if we talk about P, then here L1 is 1, L2 is 1. So the resultant L will be how much? Vector addition, it will be 0, 1 and 2, because 1 minus 1 is 0, 1 plus 1 is 2, and we will go either from this direction. If we are coming from 2, then we will decrease 1 up to 0, and if we are going from 0, then we will increase 1, and we will have all integer values. So it is 0 1 2 or 2 1 0. But here in this case, for S, L1 is 0 and L2 is 1, that is for P, L2 is 1. So the resultant L will be 1 only, because 1 minus 0 or 1 plus 0, both are equal. So it will be L equal to 1 only. But here if we talk about spin, then spin will be S1 is half and S2 is also half. So from half half, like here we got from 1 1 we got 3. For here for half half we will get 2, because half plus half is 1, and half minus half is 0. From between 0 and 1 there is no integers, they both are close to each other, so 1 0 will be only two possible values of s. So for this combination, what we got, let me erase this. So from this combination, what we got here, it is L, it is S, and we will find J. L has only one value, but S has two values. So for L equal to 1, we will take S equal to 0. For L equal to 1, we will take S equal to 1. So it will be, again, when we consider J, J will be L plus S vector. Like similarly here we are taking L1 plus L2 vector up to L1 minus L1 minus L2. So here it will be L plus S to L minus S. Since one them is 0, so it will be only one value, that is J equal to 1. But here L equal to 1, S equal to 1, so it will give 0, 1, 2. Is it clear to you? Like we talk about 1 and 1, then 1 minus 1 will be 0, 1 plus 1 will be 2. In between 0 and 2 there is another integer which is 1, so it will be 0, 1 and 2. Got it? Hello? Spectral terms. Hello? Do you want me to write the spectral terms? Yeah, it will be like that, because for s equals to 1 it is 3. You can see the s equal to 1, the multiplicity, when we write 2s plus 1, 2s plus 1 is nothing but the number of values of j. So if s equal to 1, so definitely we will get 3 values of j. If s equal to 2, we will definitely get 5 values of j. So here 2s plus, here you can see here s is equals to 1. So when we calculate from in L equal to 1, we get 0, 1, 2, that is 3 values of j. So this 2s plus 1 will be 3. So this 2s plus 1 will be 3, means if we are writing 3, and for L equal to 1, L equal to 1 we will have p, it will be 3p 0, 1, 2. Is that clear? Okay, so we will stop here today, and then we'll discuss few more problems again. So we will discuss few more problems. I think this is this is a very small problem. We can discuss it now now only. So this problem is, write down the quantum numbers L, S, and J corresponding to the 1 electron term. So this is 2d 3 by 2. So when you compare it, so can you tell me what will the value of L here? S here and J here. Here it is written plus small l, small s, small j, because it has only one electron. So for one electron, small l equal to capital L, because you are not adding. So this L is nothing but the capital L. So for here D is equals to, for D what is the value of L? It is 2. For 2s plus 1, it is 2s plus 1 equal to 2, because 2s plus 1 is written here. 2s plus 1 equal to 2 means s equals to half. So s equals to half, and this 3 by 2 is j, so j is 3 by 2. So for this state, the value of L equal to 2, this D gives L, this 2 gives this S value half, and this 3 by 2 gives the J value. Is that clear to all of you? It is very easy. So I think we have discussed many problems regarding these notations and the LS coupling. So you must be clear about it. So we will stop here today. Thanks for joining the session. I will meet in the next interaction. Thank you.